Assalamu alaikum. Welcome, students. We have comprehensively covered the theory portion of this course. Here I have opened the lab manual of machine control system containing experiments about the concepts we have developed so far in theory lectures. The experiments are conducted using a most widely used software simulation software named MATLAB. I assume all of you have installed this software in your computers. Uh, Now let's start lab 1 present in the manual. The objective is the introduction to MATLAB, in which we briefly look into how we can write and manipulate polynomials as they are necessary from control system perspective. Also, we will see how we can plot different functions in MATLAB, and also how we can write scripts in MATLAB. Uh, Here is the theory part of the experiment. I will quickly skim through all necessary points present in it. MATLAB stands for Matrix Laboratory. Uh, this is the brief description of what MATLAB is capable of. Let's open MATLAB to see how it appears on the screen. Uh, I'm using Ubuntu as my operating system. Ubuntu is the popular open source Linux distribution, free to use. In case if some of you don't know it, mostly system programmers use it, and also someone crazy like me who wants to make their life difficult by stepping out of the convenient world of the Windows operating system. Uh, So the procedure for executing an application is different than in Windows here. In Windows, you can easily open MATLAB application by double-clicking MATLAB icon present in desktop. Here is the MATLAB application. This screen name command window is used to write commands or expression we want MATLAB to execute immediately. For example, I'm writing here the expression 2 plus 3. The moment I hit enter, uh, MATLAB will evaluate this expression and will display its result immediately on the screen. The variable here named answer ANS is the default MATLAB's variable to store result if we haven't mentioned any variable to store it, as is the case here. I can also store the result in any variable of my choice. For example, if I write the this expression like 2 plus 3, a is equals to 2 plus 3. Uh, Here I mentioned variable a in which I want to store the result of the expression. MATLAB will now store the result of 2 plus 3 in the variable a rather than this variable ans. This window here named workspace, it lists down all the variables declared and used so far. We have declared and used variable a, and we have used the variable ans. The window here, the current folder named as current folder, uh, it represents the current working directory of MATLAB. Now coming towards the manual again, this part is related to the variables. Uh, You can read it yourself, I assume, so I am leaving it for you to read. Uh, Here written the definition of matrix, uh, and this describes how we can write matrix in MATLAB. Just see how it works. F is equals to, let's say, uh, 1 space 2 space 3 semicolon is used to change the row. This 1, 2, 3, these three elements are written in a single row or first row. Now, after semicolon, the content will be moved towards the second row. 4 space 5 space 6. Now, I have created a matrix of 2 rows and 3 columns, which is 2 cross 3. Now, let's go back to the manual again. Uh, Here we are given with a table. In this table, they are written some commands for matrix manipulation. You guys know all these matrix operation. You can test them on your own to see how they works. Let me point out the most common mistake here, which most of the students make, is the use of wrong multiplication operator. The steric operator is used to represent the matrix multiplication in case of array or matrix, and dot steric operator represents elemental multiplication in case of array or matrix. What I am saying is, let's say for example, we have a matrix of 2 by 2, 1, 2, semicolon, 3, sorry, 3 and 4. Uh, if I write A steric A, it will multiply the matrix A with the matrix A, same matrix, and evaluate the answer like this. But if I write A dot steric A, it will multiply elements of matrix A with its own element. So 1 into 1 will become 1, 2 into 2 will become 4, 3 into 3 will become 9, and 4 into 4 will become 16. So dot steric multiplication operator is used for elemental multiplication, and steric this operator is used for matrix multiplication. So in this operation, no matrix multiplication rules are applied, uh, which is the row of one matrix must be equal to the column of the other. However, in this operation, matrix multiplication rule must follow, which is the row of one matrix to be equals to the column of the other. Now let's go back to the manual again. Hmm, Here, a system of three equations are considered, which we usually solve simultaneously to arrive at a solution point. We can solve this system of equation using MATLAB with following procedure. Uh, you guys have done these manipulations in your grade 10. I'm just directly using this mathematical equation formed using the matrices. So here x is equals to inverse of A, which is this matrix, multiplied by the matrix B. So it's very easy to do this math in MATLAB. You just have to write INV A into B. So it will give you the solution point x, which is -2, 5, and -6 in this case. Uh, Now Let's move forward. Here there are written some commands for plotting. Let's see how we can use them by plotting this polynomial here using these different plotting commands. So I have made this program in this script. Just see how we can create the program in the script. Here you are given with this option, new script. Just press it and you will get this window. You can write all the commands simultaneously in this script, and when you hit this run button, all of these commands will execute in a row to display the output. So I am writing it. X is equals to line space 0 comma 10 comma 100. Let me describe what this function is doing. This function is creating a row matrix containing 100 points starting from 0 till this number 10. So it is dividing the number line from 0 to 10 in 100 equal parts and writing it down and creating a row matrix and storing it in this variable x. Now, polynomial is y is equals to 2x square plus 7x plus 9. Y is equals to 2 into x dot square plus 7 into x plus 9. Now here you can see I have written dot power. This symbol represents the power x dot power 2 because I want to square the elemental values of x, and I don't want a matrix operation here. Now let's plot the x and y vector we have created. Uh, this subplot function creates a figure having area to accommodate four plots at a time, having two rows and two columns, as we have mentioned here. And this one represents we are using first of the four created plotting areas. So now plotting x comma y, x area b, y, linear x, linear y. So in the first figure, first of four figure, we are plotting the function. Uh, we are plotting both x and y vector on a linear scale on both x and y axis. Uh, let's copy this piece of code. X and linear y. This function plots x and y vectors with log of x on x-axis and a linear scale on y-axis. Now this will be we will be using the second area of the same figure. copy this piece of code. Now we will be accommodating the third area created, and it will become semilog y. It will become linear x and log y. This as previously discussed, since this is semilog y, so it will plot x and y vectors with log of y on y-axis and a linear scale on x-axis. So now log log, it will also become a log and it will become 4. Now we have accommodated all the four areas that we have created. In first area we are normally plotting x and y. In the second area of the figure we are plotting with log of x on x-axis and linear values on y. In the third plot we will be using log axis or log of y on y-axis, and the x will remain the same as linear. And in the fourth figure we are using both the scale as log scale. Now let's save it. Yes. So now here you can see we have four plots in one area, four plots in the single figure. One is the linear scale. Second is the log linear scale. Third is the linear log scale, and the fourth one is the log scale. Now let's go back to the manual again. Uh, Here written some commands. I suggest you to cover it on your own. Uh, Now here a table is given in which they are written various MATLAB functions for polynomial manipulation along with their description. This function conv, which is known as convolution, is used to multiply polynomials. This function dconf is used to divide polynomials. This function poly can be used to write polynomial by specifying the roots. Poly der is used to derivate the polynomial. This function polyfit is used to fit the polynomial on the set of data. Uh, this function polyval is used to evaluate the polynomial at a given value. This function polyval m is used to evaluate the polynomial on a matrix. This function residue is used to create the partial fraction expansion. We will see how we can do it. And this function roots is used to find the roots of the polynomial. Now let's execute these commands on MATLAB. Uh, Uh, First, we will create polynomials. Polynomials are created the same way as a row matrix with coefficient of highest power written first and the coefficient of lowest power returned at the end of row matrix. So if I write P1 is equals to 1 space 2 space 3, um, a row matrix with three values, it is equivalent to a polynomial of second order with one with this one as a coefficient of x square if the polynomial variable is x, and this 3 as a coefficient of x power 0, which is a constant number. So here I have defined a polynomial x square plus 2x plus 3. Now let's define another polynomial 4, 5, 6. So this P2, the polynomial P2 is 4x square plus 5x plus 6. Now let's uh, execute this command conv. This is used to multiply the two polynomials. So let's multiply these two polynomials P1 comma P2. The answer is the third polynomial, so with order 4, maximum power 4. This represents power 0 coefficient, power 1 coefficient, power 2, power 3, and power 4. Now let's execute the second instruction, decon, which is used to divide the polynomials. So I am dividing this C with P1, C, and storing the result in again C, D C O N V C comma P1. The result is 4, 5, 6 as expected. If I divide this polynomial with this polynomial, uh, then I will get the polynomial P2, which is 4, 5, 6. Now let's execute the next function in a row, which is a poly. This function takes inputs of the roots and outputs a polynomial based on the given roots. So a is equals to poly. If I have a polynomial with roots 2 and 3, the resulting polynomial will be, if I have one root which is x which is equals to 2, and the second root is equals to x plus x 3, x is equals to 3. So this will result in a polynomial which is x square minus 5x plus 6. Now let's move towards the next function, which is polyder. This function is used to derivate the polynomial. Just see how we can do it. Polyder is equals to a. We are derivating this polynomial, so this 6 will become 0. Here, as evident, this is the coefficient of x square, so it will become 2x, and this is the coefficient of x, so x will be removed, and here we are left with minus 5, and this is a constant number, so the derivative of this constant will be 0. And now going back towards the manual again, I think you guys can explore these functions on your own, as it is getting pretty basic. I'm now describing this function as it is the important function. This function takes the inputs of a transfer function in the form of numerator and denominator polynomial, and returns three vectors R, P, K. Let me describe what these vectors are. Uh, if we have a transfer function, I'm writing here. If we have a transfer function t is equals to minus 4s plus 8 and s plus 2 and s plus 4. Uh, then I can make a partial fraction of this transfer function as a over s plus 2 plus b over s plus 4. So these two values here represented by vector p, and these two values will be represented by vector r. And the vector k will only appear if we have improper transfer function. You can consider the example to see how it works. Now let's take this example to find the RP key values. Here B is equals to uh, minus 4 and 8. A is equals to uh, 1, sorry, 1 and 6 and 8, and R T K will be equals to residue B comma A. So here the value of R is minus 12 and 8. Poles are minus 4 and 2 as expected, and the value of k is the vector k is 0 as we have considered the proper transfer function. So I can write the partial fraction of this transfer function as minus 4s plus 8 is equals to s square plus 6s plus 8 will be equals to uh, the residual minus 12 value will come above the pole minus 4. So minus 12 s plus 4, and the value 8 will come above the pole minus 2. So the plus 8 over s plus 2. So we have converted this transfer function into the partial fraction. That's all about the introduction of MATLAB. I strongly suggest you to read theory part of the experiment uh, on your own, as I have discussed only the important points which I thought was necessary. Rest is your homework to cover. There is a lab exercise at the end of lab session 1 here. Solve it. I will give you template of submission so that you can formally submit these exercises. Let's end today's session. Allah Hafiz.